Our conversation today is recorded live at Cisco Live in San Diego, and our discussion explored the next evolution of connectivity as Cisco announces major advancements in its Wi-Fi 7 portfolio. From the new CW9179F access point to powerful integrations with Cisco Spaces and Campus Gateway. Today, I want to unpack how all these innovations are transforming high-density environments like stadiums, campuses, and hospitals into intelligent, adaptive, and secure digital spaces. And Matt and Jerome will also be discussing the growing role of AI in managing complexity, streamlining network operations, and building more resilient infrastructures without overwhelming IT teams. So with wireless now touching everything from robotics to real-time analytics, how are organizations preparing for what comes next in connectivity? And it's on that note that I'm going to introduce you to today's guest. Well, a huge thank you for stopping by and speaking with me today here at Cisco Live. Matthew, first of all, could you tell everyone listening a little about who you are and what you do?
Sure. So I'm Matt MacPherson. I'm the Enterprise Wireless CTO. And so I look at a lot of different areas. I look at regulatory, what's happening with Spectrum. We're obviously very much and deeply involved in the standards. So Wi-Fi 7's out and we've released product, but the team is actually working on specifications for Wi-Fi 8 now. So we're the ones that are kind of looking, okay, what's the next generation? And so we're very much involved in the standards as well. And a lot of the wireless innovation that's going on, whether it be Wi-Fi or we're talking about 5G and how we integrate these things, how do we auto onboard with open roaming, a lot of that comes out of the CTO team.
Wow, you've got an incredibly cool role there, haven't you? Already talking about Wi-Fi 8. And obviously, you've got Jerome joining us as well. Jerome, could you tell everyone listening a little about yourself too?
So I'm Jerome Henry. I work with Informat, and I'm looking into the future of standards. So I'm primarily working for now on Wi-Fi 8, and Wi-Fi 7 is the brand new thing, but Wi-Fi 8 is already in the making. And also working on ultra-wideband technologies and BLE technologies for the 3 to 5 years horizon.
And you say that, Jerome, you're working on Wi-Fi 8, but I've got a book in front of me here called Wi-Fi 7 in Depth. Tell me a little bit more about that book.
Yes, attending the IEEE and the Wi-Fi Alliance meetings on the design of the Wi-Fi 7 and 11BE, we realized that a lot of people, see the result, which is the standards, but they don't understand what were the challenges that we were trying to solve and why we made the choices we made in these protocols. So we thought with a couple of colleagues, it would be interesting to give that background, not just explain the standard, but explain how it came to be, what it intends to solve, and why we made those choices.
And what was the one key takeaway of the book? For anyone that does look it up now as we're talking, what should they be walking away with if they were to buy that book?
So Wi-Fi 7 is more than just multi-link operation. It's more than MLO. It has a lot of things to optimize everything which is real-time and is latency sensitive. So it's more than just having two links, and Matt will tell you much, much more about that.
Well, I'll look forward to reading that on the plane ride home. But Cisco, here at Cisco Live, made some pretty big announcements today, especially related to Wi-Fi 7 and the entire portfolio there. So what are the big highlights, and what do they mean for enterprise connectivity?
Yeah, we're really, really excited about what's going on with Wi-Fi 7. Sometimes we see these different releases and we say, oh, another Wi-Fi release, but sometimes it's hard to absorb actually some of the capabilities that we're doing. Now at Cisco, we've been on a journey for a long time to make wireless, especially unlicensed wireless, as predictable and as deterministic as we can. So in other words, how can you have some level of assurance that you can maintain the throughput in high density environments with all these new things, whether it be a robot or it be an AR headset? How can you assure that you're getting the latency type characteristics that you need for this next generation of applications, especially with the amount of density that we have on these networks? So with Wi-Fi 7, like I said, it's the next step. I mean, if I do a little bit of history, with Wi-Fi 5, what did we do? How did we design networks? Really, if I had to put it in very high-level terms, we would over-provision the network and we would under-subscribe it. And then as we started to consume those resources, what would we do? We'd provision more, right? And we went into Wi-Fi 6. We had a fundamental change in what we were doing because we enabled a technology called OFDMA. Now, without getting into all the acronym soup, basically what that means is that in Wi-Fi 6, we could schedule both in the frequency domain and in the time domain. So that means we can have multiple conversations going on simultaneously without colliding. If we're not colliding, we're not inserting latency, right? So we're providing a much better experience. That came with 6. Now with 6E, of course, we address what's known as the collision or the interference domain, right? So what do I mean by that? Wi-Fi isn't unlicensed, and anything can light up unlicensed legally. So you have all these little things that are showing up, and you have all these devices. Maybe it's a light bulb, maybe it's something like a heart rate monitor in a hospital. So there's really an incredible number of uses that we have here, but these things have to collaborate, and if you have lots of uses of unlicensed, they can start to interfere with each other. So when we went to 6E, we opened up by the FCC in the US another 1,200 megahertz. So there's 2 things that we had to do. One, we had to make sure we had a stack that could schedule traffic based on the policy of the access network. What's mission critical to you? And 2, we needed to be able to protect from interference so that that experience wasn't destroyed. So that's really what we did then as we went into Wi-Fi 7 is a new set of capabilities that enable an IT manager to get a predictable experience even in high density conditions, even when connecting people and things, right? So that you can actually solve that next generation set of use cases.
Wow, incredibly cool. I'm curious, what kind of challenges are AI-driven enterprises facing with maybe current wireless infrastructure? And how is Cisco responding to some of those needs with its latest solutions? Because predictably, we're at a tech conference, everyone's talking about AI, but there comes certain responsibilities, challenges, and opportunities with that, right?
Yeah, AI has gotten quite famous. And so, when you walk around a tech conference now, it's AI this and AI that. But what I'm excited about specifically, and a lot of the work that Jerome is doing, can I actually say that you're working on an AI book, or I guess I just did. So we are looking at the next generation. And so the thing about AI is we've been applying it for a while. So some people don't realize that. If you look at what we do when we manage the channels on a network, if you look up on the ceiling and you see all these APs, that has to be managed. That has to be put on specific channels, and that has to be put at specific power levels, because otherwise APs will actually interfere with themselves. And so we do a channel management plan. Now in I'll say the old days, and I remember the old days because you see I have a little bit of gray here in my beard. We had to do that all manually. Now what we're doing with AI-RM is that the AI can look at the current consumption of the network and what's connecting and how, and then it can manipulate that RM, that radio resource management algorithm for you to optimize the result. What's that result? The most throughput with the less latency for the most users. So that we've been doing for a while. So Cisco has, some pretty good experience here, right? Now we're going to the next generation, and we're applying AI to a lot of additional functions and capabilities. So I think it would be great to actually talk about some of the things that we're doing there, like how are we applying this in the next generation, even in the Wi-Fi 7 protocol set.
And I'd love to hear more and bring to life some of the technology that we're talking about here. As an ex-IT guy, every concert I go to, stadium or anything, I'm looking for the APs, trying to work out where all the tech is that's making this experience possible. And I suspect that you guys are the same. So for anybody that has a digital experience anywhere, can you tell me a little bit more about how this technology is changing the game for anything from stadiums to large campuses? Is there any stories you can share to bring that to life?
Yeah, it wasn't that long ago we would talk about high density and how we would implement enterprise class APs to address high density. And so when you think about something like a stadium or a venue like Cisco Live, for example, that we're sitting at right now, what high density meant that there were a lot of people in a tight space that are all trying to connect to the same network, that all are expecting certain capabilities. And of course, those use cases and those applications are demanding more.
All made up of water as well, like 80% water, those people.
It's amazing that you actually say that, because when you set up a venue like this, it is a challenge. And why is it a challenge? Well, you like to test the network. So you put in the APs and you test the network. When do you test the network? Before the event starts. You kind of want to know what you're going into, right?
Yes.
So when you set that up, everything seems to work pretty good. But guess what? In 1 week, all these exhibitors come in and they build booths. We put in all these walls. And to your point, tens of thousands of people come in And what are they? They're basically sacks of water that are walking around that are changing all the RF characteristics. So you have to be able to respond to that in a dynamic way to make sure that you're still, even though the RF characteristics have changed, are able to make those adjustments so that you can address that connectivity to still meet those needs, even as things are changing out from under you.
Wi-Fi 7 also promised to reduce latency, faster speeds and stronger security. From a business perspective, for that business leader listening, what makes these advancements so timely, would you say?
Yeah, it's like I said, if we looked at the older generation of Wi-Fi, we get back into Wi-Fi 5, we did this over provisioning and under subscribing, and we got a pretty good experience. And because the way Wi-Fi would work is that it would just go on the network. And if you have very low utilization, that's actually very responsive. Because if most of the time you can get on the network, it works pretty well. But in situations like what you were mentioning as you go into a stadium, or even enterprise now, because with the advent of things and everything connecting to Wi-Fi, what we find is that more and more high density is happening everywhere. So we have to be able to better manage that. So what we've done in the next generation of Wi-Fi 7, is implement mechanisms so that we can actually shift where we're putting traffic in the spectrum in real time in order to assure that traffic is getting through, and it's getting through in a very timely way. And so we can actually get into a couple of things. I mean, I have Jerome sitting here that's wrote the book on it. He mentioned MLO. I mean, it's kind of interesting because, Jerome was saying, there's more to Wi-Fi 7 than MLO, because everyone immediately goes to MLO. But actually I want to take a second to touch on MLO, because MLO is actually pretty cool. So why don't you tell us, Jerome, a little bit about MLO, and then we can talk about what we're building on it.
Yeah, because, MLO, as a technology, it sounds simple. You just connect to two radios at the same time as a station. So it looks like, okay, so what, have more bandwidth. And technically it's true, but it's actually a bit more complicated, because if you have two radios in your phone, for example, that means you consume twice as much energy. That means your antennas have to be separated. So there is a lot of complexity that appears when you do that. So doing it smartly means that you enable multiple connections at the same time, but you only use the one you really need. And so if you're in a home and you are streaming, some video, so maybe 2 links is what you need to just get, a good buffering structure on your, video that you're watching. If you're playing a game, maybe you want to have those 2 connections as well. If you're an enterprise, as Matt was saying, the deal is more about what traffic matters, which one is latency sensitive, and how do we organize all these devices connecting to the network so that you give the best throughput to all of them, not just, satisfy one single device requirements, but all these devices together. And that means that in the standard itself, there are multiple modes of MLO, which depends very much on what is the complexity of the device connecting. So the access points support all these modes, but the clients do not. And then, in the architecture of the network, the question becomes, how do you orchestrate these different possibilities? How do you understand the traffic they send? And how do you make sure that you optimize for their need? That is to say, not everybody needs to have, very low latency. It depends very much on the traffic. And that's where things become much, much richer in an enterprise environment than just, MLO, I just connected twice.
And I would ask everybody listening to see how many devices are connected to their Wi-Fi network now. We go back 10 years, there was probably a handful. Now, when you take in that urgent work call and video conferencing, somebody could be downloading a 100 gig game on their Xbox, 4K streaming, smart doorbells, heating, and the list goes on and on. It's not uncommon to have 100 plus devices just in a home. So when we've got Wi-Fi 7 and the technology in place, so from there, what are you building on that?
So yeah, and all these devices, some of them are moving, some of them are not moving. Some of them have, requirements, which means that they need to send a packet at special time because some server needs to receive it. And it has to be now. You cannot just miss a packet. So understanding all these requirements is fundamental to the organization of the network. So once we have these basic things, we have 3 radios to work with. We have 2.4, we have 5 gigahertz, we have 6 gigahertz, and we have different types of applications to work with, which means that there is a lot of things we can do to optimize, the experience of these devices. One of them is to reduce the latency. And in Wi-Fi 7, beyond just this dual connection, there are multiple features that were developed to say, can you reduce the latency by allowing some communication on one radio, on organizing who really needs to get to 6 gigahertz, for example. If you are, as you were saying, a door sensor and you kind of keep alive every minute, I don't need you to go to a band that is super clean, like 6 gigahertz. I can just leave you on 2.4, maybe on 5 gigahertz. Now, if you are a nurse and you're having some paging communication, you probably need to be prioritized and therefore be sent to that 6 gigahertz band. If you're in a hospital and you're a patient playing a game, maybe your game requires low latency, but is it the same type of low latency that you need as the nurse? So, the structure of what we build is the orchestration of all these needs together in a network.
Yeah, and one of the points that I would make is if you listen through those examples that Jerome gave, what is prioritized is very vertical dependent. So if you're a big warehouse and you're moving equipment or you're moving your inventory around using robots, that's their mission critical application. If you're in a hospital, like Jerome was saying, then the doctor paging and the communication system, the ability to send x-rays, ability for the nurses station to talk to the rooms, the medical equipment that's connected to the patients, that's their mission critical application. But then you go into a K-12 school and you know what? It might be RoboBlocks.
Yes.
So what we have to do, that's what I mean is when we're connecting that upper layer policy to that lower level scheduling, that is really venue by venue specific. And we want to give each IT department the ability to specify what's important to them and then schedule that on the network before we schedule the other traffic. Now that sounds like some basic quality of service, but it's not the same. So when we talk about basic quality of service, what we mean is we have a flow and we mark the flow, and then based on that we queue it, right? I'm talking at the lower layer when it comes to the scheduler that's moving packets actually into the air interface, being able to send that traffic in a way that's low latency. So this gets right down to the lower layers and how Wi-Fi 7 works to achieve these types of things.
And how have these industries and examples that you've given, how have they responded to some of these changes?
Oh, extremely positively, right? Because in some of the new announcements that you've heard, we also have some technology that Cisco's been doing a while, like CURB or sometimes ERB, right? So that ultra reliable wireless. And that's what's going in some of these announcements in these APs. And so we've already had the ability with very good reliability to apply mobility. So you can think of it as a stationary AP and then a connection that's going to a mobile IP. So you can mesh these APs together, but you can also have nodes that are moving, right? And you're maintaining that connection very much in real time. Now, at the same time, the industry is going towards that more deterministic, that more reliable type connectivity, and that's what we're doing in Wi-Fi 7. So if you combine the capabilities of CURB, that mesh type technology, also with now end devices, the typical things that you want to connect. Here's an iPhone, a Galaxy, your laptop that you have there. So now what we can do is we can connect standards-based devices, and we can also apply specialized software so that we can move things around the network in a very seamless way.
Wow, incredibly cool. Cisco Campus Gateway, that's something that also offers cloud-managed capabilities for large-scale networks. So how is that helping reshape the way that IT teams can manage things like mobility, scalability, and that user experience we're talking about?
Yeah, this is very important because if you look at a network, you can kind of look at it in layers, right? So you have an AP and it's talking to multiple devices. So the device itself has a view of the network. And we can talk a little bit about that as well because we do work with our partners to pull in specifically device analytics. And then you have an AP, it has a little bit of a broader view, right? Because it's talking to all the devices that it's currently connected to, and so it can manage across those devices based on these policies that we're talking about. So now you go AP to AP. Right? And you have to be able to move across that. So you need something that's looking at that broadly. Now, your cloud management system is going to be able to manage that. It's going to be able to run the latest code. It's going to be able to display all the analytics that you want to see so you know what kind of experience is happening on the network. But when it comes to doing real-time things, right, and in some of these cases, some of the AI that we're applying to this, whether it's AI RRM, but specifically mobility as you're moving across the network, you'd like to be able to manage that locally. And so you would do that with an on-prem gateway. right? So you see how it's solving that problem. As you go towards the edge, you're going to be more real time. And as you go towards the center, it's going to be more comprehensive as far as the information that you have, but it's going to become less real time.
So just to further bring this to life, how are you seeing Wi-Fi 7 and maybe AI-driven tools like Cisco Spaces? How are you seeing these things converge and help build a more intelligent and responsive work environment?
I have to say, we are so excited about Spaces and the capabilities that we can do in Wi-Fi 7 that actually enhance the Spaces experience. So that's a really loaded question. It's almost hard to know where to start. But I mean, if you look at our Wi-Fi 7 AP, you know what it is? It's actually a radio platform. Right? So we do .11, sure, we have Wi-Fi, and that is our key connectivity metric, and we have all these features and prioritization and densification and latency capabilities to provide the best experience. But you know what else is in there? You got a 15.1 radio that's doing what? BLE, right? You have a 15.4 radio that can do IoT type technologies. You have an ultra-wideband radio in there that's giving you incredibly accurate blue dot. And so you have a GPS radio that's in there so that the APs can self-locate themselves. So think about that, right? If you talk to most of our customers and you say, do you know where all your APs are? And they're like, well, we kind of do, but when we painted that room, it got moved, or whatever, that wall moved, or whatnot. Especially big customers that have thousands of APs, right? So you know what the APs can do now? They can self-locate.
Oh, man.
So they're using these next generation technologies like fine timing measurement. So think of it this way. So GPS isn't indoors, right? You can't see the satellite, but these edge APs can, right? So they pick up the satellite, they locate themselves, and then based on their location, they locate all these hundreds of other APs on where they're actually installed. Now, that you can say, well, that's great. Now I know where the APs are. It's easier to manage. I know where to put the ladder if I need to, do something. But it's not just that. Everything that Spaces does anchors on that location of where that AP is, right? Because what is it doing? It's determining where people are, where devices are, based on triangulating using these signals. FTM, we'll talk about it in a second. Using those signals to find people. If the AP is not where they think about it, where they think it is, then it's going to get a miscalculation, right? And it's going to say you're someplace you're not, right? So the first thing you have to do is actually have accurate location in the network where those APs are, and now they're locating themselves. So the whole idea, let's make this as easy for IT as we can, right? So I'm going to let Jerome talk a little bit about FTM, because FTM technology now is in all the chips. If you have a Wi-Fi chip, then you have fine timing measurement, and it's some of the best location we've ever had. So now that we have that location, we can actually apply that location to how the network operates. And we'll talk a little bit more about Spaces.
All right. And it's really great because FTM, we initially started using it for AP to AP ranging, so we can measure the distance between access points. And as Matt was saying, maybe the AP on the west wall sees some satellites, but not all of them, not enough. And the AP on the east wall sees some other satellites. With this AP to AP ranging, we form a sort of graph where the APs combine their understanding and knowledge to form a sort of a gigantic floor-wise GPS receiver to know their own position. But then, of course, as Matt was saying, most of the client device chipsets have support for this fine timing measurement technology already. So when we enable it for the AP to AP use case measurements, we made it available also for customers to use it, which means that now you can navigate in a venue and find your position even if GPS is not available indoor. You can still find your position within 2 meters-ish accuracy. And with ultra-wideband on top of that, and all the major brands also have ultra-wideband technologies as well, you bring this accuracy down to a few centimeters, a couple of inches, which means I can know if your phone is on the left side or the right side of your laptop. And I say, it's me, the user, because the way we designed it is privacy respecting, which means that you know where your device is because you have access to that device. The infrastructure just provides you the support to get that knowledge, but the infrastructure cannot track you. So it's a very interesting mix of navigation and privacy at the same time.
And then you're looking at that and the power of that technology. And what excites you about how that's then used with the spaces, if we go back to that?
Yeah, I mean, so there's a whole lot of use cases. A lot of people will immediately go to some of the basic ones that we've heard about before, like you want to have a blue dot indoors, you want to do indoor maps, you want to be able to do wayfinding, things like that. But what we're doing now is optimizing. If, say, take an enterprise space, we're optimizing how that enterprise space is used so that we can increase the productivity of the people that have the use of space, and we can optimize that space. So what's the occupancy in a room? When I come into a building, where do I find a free room? Over time, how are the rooms used? Are we making efficient use of them? Do we need more rooms that are small for 4 people? Do we need more rooms that'll hold 20 people? So all of these types of things allow you to then optimize your floor plan for how your business and the employees you have work. So now you can find where people are, you can find where the availability is, and you can do that as soon as you walk in, connects to your phone, scan a QR code, and it'll tell you how to get there and find it. So it's integrated with all the wayfinding as well.
I can hear light bulb moments going off in people listening around the world. And when enterprises look at future-proofing their wireless networks, what role do you see simplicity, automation, and security, all these things playing in that process? Anything that you'd recommend or advise? You must get asked these questions a lot.
Yeah, so this is where AI really comes into play, because you're getting so much data off the network, it's actually hard to peruse. Right? And what is AI really good at? Going through a lot of data and then giving you a result. So what you're doing is you're enhancing the ability to manage the network based on the conditions that are currently happening in your network, even in real time. So AI is a tool, and it's an extremely effective tool, right? And you're going to get to better conclusions than if you're trying to figure it out and you're trying to look at all those details yourself. I mean, just take into the case setting alarms. When we set alarms, you can get a lot of alarms on your network, and if you set things too sensitively, all of a sudden there's all this stuff that's actually noise and not really telling you what's going on in the network. What can AI do? Tell you what to look at, why it's important, and even make suggestions on what you might want to change in order to improve that particular situation.
And a question to both of you to close out our conversation today. If we look beyond today's announcements, are there any trends or breakthroughs that you're most excited about, especially when it comes to the future of wireless connectivity? And Jerome, I'll let you go first.
Wi-Fi is changing all the time, right? A couple of years ago, we're thinking everybody's going to have AR, VR headsets. It didn't happen as fast as we thought. However, what we see is that, as you were saying before, everything now is connecting over Wi-Fi, which means that no longer you can just afford to have connectivity. You have to custom design your network in near real time for whatever is showing up in your network. And what is exciting is that with this advent of AI, we are now getting to a scenario where you can achieve that kind of customized real-time optimization of your network for each of your devices. And that is exciting because, my ambition is to be forgotten. That, one day things will just work and we won't care that, it didn't work before and we had to have experts doing all these things because it will just be automatic.
It's funny because when I arrive at this hotel, the first question I want to ask is the Wi-Fi password. I'm hearing the spiel about breakfast is served at the bar, opens out. Hold up, what's the Wi-Fi password? That's all I need. Over to you, Matt.
Yeah, I was just sitting here thinking. So the problem with forgetting Jerome is he needs to quit publishing books. It's like, he's got all these technical books out here, so I think it's going to be pretty difficult to forget him. But look at this book. This is Wi-Fi 7, right? I'm flipping through the pages, right? And there's so much there. And it's every time we do another release, some people, when they look at something like RF technologies, they see a little bit of black magic. And in RF engineer, there's only so many of them, right? And we don't want everybody to be a rocket scientist. And that's why what we're doing is we're improving these tools so that you can be given the information, even pointed to the information that is relevant to you, so that you can better manage the network. What's happening with a lot of IT departments? They're being asked to exponentially increase the number of devices and things that are connected to their network. But what they're not given is a lot of additional headcount to do it, right? So we have to do these things smarter. And what Wi-Fi 7 does is it gives us this platform to achieve that, right? A platform to actually be able to put power back in IT's hands to specify what's mission critical, to see if it's getting it, and to make adjustments when it's not. And so that's something that used to be so manual. I hate to say it, but I've been at Cisco for a while. I can remember doing this in the command line.
Yeah.
Right? We're in a different world now. We have to move much faster. And so having this platform where we can do some of that functionality and then do it intelligently is incredible to build on. I'm actually excited to see what next things are developed on top of these capabilities. Because as the capabilities go up, the use cases expand. Right? You were talking about Spaces. Look at what we're achieving with Spaces. That wasn't a Wi-Fi thing in the past. Now it is a Wi-Fi thing because even Wi-Fi can detect presence of people that are in different rooms and whatnot, and it becomes very operational and it becomes very efficient. So we're very excited about what's going on with Wi-Fi 7 and what our customers can do with it. I think our customers are very excited about it as well. And hopefully, as we build and AI helps us to build these next generation of networks, we'll meet those demands and new applications and services will come through it.
Well, the book is Wi-Fi 7 in depth. I urge anyone to type that into their bookseller of choice. I'll also include a link in the show notes so people can find it nice and easy. But anyone interested in some of the huge announcements, there's been a lot coming out this week about wireless and connectivity, and just keep up to speed with the work that you're both doing. Where would you like to point everyone?
So obviously go to the Cisco webpage, right? And if you look at Cisco Live, you'll see all the announcements. So we have a pretty good overview of what's going on there. And there is really a lot going on because you come to Cisco Live, obviously, I like to think it's all about wireless, because that's my field, but obviously there's a lot of things that are going on in switching and what's going on in collab and how we're integrating these solutions together. So visit the Cisco Live website, see what some of the sessions are, learn some of the new technology, and of course talk to your account team.
Well, thank you for passing me the book. I'll be reading that on the way home, and we'll reconvene. We'll meet here in 12 months' time, and you can hand me your AI book. How's that sound, Jerome? Thank you to both of you for joining me today. So what does the future of wireless look like when AI, automation, and location intelligence all converge? As we heard from Matt and Jerome today, Cisco's Wi-Fi 7 innovations are not just raising the bar. They're setting new standards for how enterprises think about performance, scale, and user experience. And whether it is smarter spectrum use, ultra-precise indoor positioning, or just the ability to dynamically prioritize traffic based on your business needs, I think it's clear that we're moving into a phase where wireless isn't just about access. It's actually about strategy. For IT teams, simplicity, automation, and security, they're no longer optional. They're foundational. And with technologies like Cisco Spaces and fine-tuned scheduling powered by AI, the network becomes an active partner in shaping better business outcomes. So as devices multiply and demands grow, how ready is your wireless infrastructure to respond in real time and evolve and adapt with you? Email me, techblogwriter@outlook.com, LinkedIn, X, Instagram, just @NeilC. Hughes. Love to hear your thoughts on this. So I look forward to speaking with you all again very soon.